Okay, guys, we're going to look at uh, indicator 9 today, which is scatter plots. Okay, so this is scatter plots here. Let me hide this here. Uh, and guys, there's a lot of these on your iStep. These have seen this showed up quite a bit. And I'm going to tell you some important parts of scatter plots. Okay, this is just a vertical axis and a horizontal axis, and we're just going to plot a piece of information, which is what we have down here: experience in years, and then your hourly pay. So we're going to make a scatter plot with this. So one of the things I think it's important is to make sure we have a title, number one. Okay, so we're talking about experience and hourly pay. So let's call this your pay per hour. And guys, it can be a little bit different. You can title it something a little bit different than others. It doesn't have to be exactly the same. And then the second thing you need to have is you need to make sure you put labels on here on what we're talking about. And specifically, make sure you label both of your axes, your vertical and your horizontal axes here. Okay. Now I'm going to tell you the horizontal axis, usually whenever there's money, is what we usually do is put that on the horizontal axis. So I'm going to do the same thing here. And I'm going to call this dollars per hour. And then the vertical axis, we'll call this experience. Okay. Not real great. And then we're going to put this, we're also going to put that it's talking about in years. Uh, so there's to me the second important thing is that you label both your axes. And then to me, the third important thing, number 3 on my list, is to be consistent. So, like when we're talking about money here, okay, we go from $6 to $19. So don't go 6, 8, 25, 10, 12. No. Whatever these lines are, make them a consistent distance between the two. I'm going to say let's go ahead and make this let's make this $3. So for everyone, it's 3. So this will be 3. This will be 6. This will be 9. This will be 12. This will be 15. This will be 18. This will be 21, 24, and so forth. If you wanted to do every 2, you could do every 2. You probably don't want to do every 1, but some you may. You may want to go by 1s, 2s, 3s, 5s, whatever it is, maybe even halves in some situations. Whatever it is, be consistent. Same thing with the horizontal axis. Now we go from 1 year of experience to 10. So I think for this one, I'm going to go every 1. So 1, 2, 3, 4, 5, 6. This thing's jumping around on me, guys. Sorry. 7, 8. Let's see if we can get this here going. 7. Sorry, guys. 7, 8, 9, 10, 11, and so forth. Okay. 11. Sorry, guys, this thing's jumping around here. I'll get it going. This is 10, 11, so forth. So whatever it is, be consistent. And then the next thing is you want to be accurate. Okay, you need to be as accurate as you can when you're doing this scatter plot, which is really what we're doing here, part A, drawing the scatter plot. So for 1 year of experience, you make $6 an hour. So over here in the graph, for one, I want to make sure I'm at $6 per hour. For 3 years of experience, it's 825. So 3 years, 825 would be a little bit past halfway here. For 4, it would be $10. So 4 would be just a little bit past the 9. For 6, it's to 12. So 6 and 12 is definitely right on the point. And then for 10 years, it's 19. And 19 would be just a little bit past the 18. Okay. So just a little bit past the 18. So there. So that's the fourth thing is let's be accurate. Okay. And so that's drawing my scatter plot. The next thing is, does the data have a positive, negative, or no correlation? I know you've probably done this before, but here on the next page, I put 3 graphs. I just want to show you this is a positive correlation. Okay, and it's positive because as we go on the horizontal axes, the coordinates seem to go up. So that would be a positive correlation. This would be an example of a negative correlation if your points look like this. So as you go horizontally, the points go down. And then having no correlation is if you just have a bunch of things out here and it doesn't really look like it has a trend of going up or down. So as I look at this graph, it definitely looks as I'm going down this way that it's going up. So this definitely has a positive correlation. So really, guys, for the most part, yours will always be positive or negative. The third thing they ask us to do here is draw and write the equation of the best fit line. So let's draw it first, and then we'll write it second. So all we're going to do, you can take a ruler here. I'm going to take my line tool, and we're going to draw a line that goes through this set of data, and it should be pretty close to it. So, guys, it can go through a point. It doesn't have to go through points. I would always suggest that you try to make this go through a couple of points that are on the corners. Like I see these two right here that are both on the corner. So I think I'm going to try to make my line go through both of those the best I can because that's really going to help me. And that one didn't quite go where I wanted it to. It's actually, I think, a better line. We do something close to that. So that's it, guys. I'm going to tell you that some of you will have graphs that are a little bit different. There are some variance in answers here. I'm trying to make that go through both those points. It's pretty close. And so there are some variances for answers here, but not a lot. Okay, they ought to be pretty similar depending on how you graph. So the second part is we're going to write the equation for this line. And really, it's going to involve me doing part D first, which is what is the rate of change? Guys, the rate of change is just a fancy word for what is the slope of this line. Okay. Now, one of the ways we found to find the slope is to take 2 points that you know, like this one right here and this one right here. We just made a little rise over run. So how much does this rise? It's 1, 2, 3, 4, 5. Now this runs 1, 2. But let's remember, every one of these in between here were 3. So it actually goes from 6 to 12, which means instead of 2, it's really 6, because we did every 3 here. So my slope is rise 5, run is 6. So the rate of change is 5 over 6. Here's the question. What does that mean? Well, 5, remember, is your years. So that means for every 5 years of experience, and 6 is the amount of dollars you're getting per hour. So for 5 years of experience, you can see a raise of $6 per hour. Okay, so that's basically what my rate of change or my slope is saying, is that for every 5 years of experience, you can expect to see a $6 raise. And you can see that here from 1 to 6. Instead of making $6 an hour, you make 12. From 4 to 10, that's 6 years. So it'll be a little bit more than $6. It is. It's 10 to 19. It's $9 an hour. So there's what the rate of change is. Now, the rate of change is your slope, which, guys, is going to help you write the equation of this line, because we're going to write it in slope-intercept form. Y equals mx plus b. And so I do have my slope here. Okay, so it's y equals m 5/6 x. And then the question we have to do here is we got to find our b, our y-intercept. So where would this line cross the y-intercept? Boy, I'm going to tell you, it's hard to kind of pick out here. Other than that, you can do this. You can take one of the points here, like 6, 1, okay, which is this point right here. That's 6, comma, 1. And you can put that in for your x and y here and solve for your b here. So it's going to look like this. Y equals, whoops, it's not going to be y. I know what my y is. Sorry, my y is 1. So 1 equals m, which is 5/6. And I know my x is 6 plus b. So it's 1 equals, the 6 is pretty conveniently cancel out here, 5 plus b. And I can subtract 5. So I get b equals -4, which ought to make a little bit of sense, guys, because look, that line would definitely go down here into the negatives. So there's your equation for your line here. Y equals 5/6 x minus 4. Now I'm going to tell you, I would, like, if I had this kind of correlation here, if I go back to the other slide, when I draw my line, I would think about maybe seeing if I could make it go through the y-intercept, and then, guys, you could just pick the y-intercept off of where it crosses here. Same thing if I was doing this correlation. This one would definitely be a little bit easier. And then make it go through the y-intercept or the y-axis, that vertical axis, and you can pick your y-intercept off here. I'm going to tell you, you probably if you graph this right, won't have to do this very much. Okay. Now, the two things that we really like to do with scatter plots are these. Make predictions depending on what we found. So it says use your prediction equation to find the experience of somebody who is paid $14 an hour. So guys, being paid 14, your pay was that bottom, which was your X. Okay, remember our pay, dollars per hour, this is my X-axis. So what I'm going to do is I'm going to take this equation and go y equals 5, 6. But instead of X, I'm going to put 14 in for X minus 4. And then I'm just going to go ahead and crank this out. So let me see, 14 over 1. The 6 and 14, they do simplify to be 2 and 7. So that's 35 over 2 minus 4. Then 35 over 2 is 17 and a half minus 4, which is 13 and a half. We're talking about money here. So, I'm sorry, we're talking about years here. Sorry, Y is years. So it's 13 and a half years of experience if you were paid around $14 an hour. Let's see if that makes sense. Maybe. Yeah, I'd be somewhere in between here, 6 and 10. And you could probably see that my 19 is a little bit below my line. So maybe that's a little off of where my equation ought to be, but that's okay. It's consistent with what we had here. So this one is use your prediction to find the equation of somebody that has 14 years of experience. So a little bit different, but in this case, the years are your Y. For the paid, it was your X. So for this case, I'm going to use that same equation, and I'm going to put 14 in for my Y here. So 14 equals 5/6 X minus 4. And now I've got to solve this for X. You guys might want to just multiply everything by 6 to get rid of that ugly fraction. That's fine. So it's 84 equals, 6's cancel out here, 5x minus 24. So you're going to add 24 to both sides. Okay, so we're going to get 5x equals, what is that, 108. We're going to divide by 5. And in this case, it would be 20, oh, it would be at 21 point, oh, that would be 21.6. So $21.60 per hour would be, you would expect their hourly rate to be for 14 years of experience. So guys, that's a scatter plot, and then just making a couple predictions off of that. And really, both of those will be using your equation that you write. And guys, you would always use slope-intercept form. Find your rate of change, which is your slope. Make sure your graph, when you draw it, make sure it goes through a couple lines. And if you can, make it go through the y-axis, which will make this y-intercept much, much easier. Okay, guys, you got a couple worksheets to work on these the next couple days. If you have any questions, let me know here. Okay, thanks, guys.